Hello, welcome to the order of operations video. You might think you know something about order of operations. Not that I want to deny that you do know something about order of operations. I just think that you're going to have your mind blown with the complexity, or seeming complexity, that order of operations problems can give you. But with the right tools and the rules, you're going to be able to take what looks like a really complicated problem and get a very easy, simple solution. So let's start. Title: Order of operations. Are you writing this? Thank you. Okay, order of operations. So first I kind of need to prove it to you, okay? So I'm going to have you try to evaluate 5 plus 4 times 6. I use the word evaluate because I see a lot of you ask me questions about what evaluate means. It just means solve. Okay, so solve this. Pause and do that. Okay? Well, there's a lot of ways you could have done it. Well, not a lot. 2 different ways you could have done it. You could have added first. So if you add first, you get 9 times 6, which equals what? 54. Okay? Or you could have multiplied first. Okay, so if I multiply 4 times 6, 6, 12, 18, 24, so I get 5 plus 24, which equals what? 29. Okay? So we come up with a problem. If I'm an ancient mathematician, I look at this and I think, well, that's not right. I can't have a problem that has 2 possible solutions. I need some rules. So I'm going to have to tell people what to do first. Should they multiply first or should they add first? So maybe you already know the rules. I'm about to lay them out. We're going to draw them out. But there are rules. You're not allowed to just choose. You don't get to decide, oh, I want to add first or multiply first. There's rules to it. So let's write down these rules. So the order matters. The order definitely matters. And mathematicians have decided which order you're allowed to do things in. And we call that, maybe you already said it, Pemdas. Okay, so that starts with a P, E, M, D, A, S. So each letter represents a different thing. I love things like this in learning because they just make it easier to memorize. Okay, so Pemdas. Maybe that's good enough. Maybe your brain remembers Pemdas, no problem. Maybe your brain doesn't remember Pemdas and you want something else. Sometimes I say, please excuse my dear Aunt Sally. Okay, you might have your own. Some teachers have slightly different versions of this. I'm sure they're all the same, though, because all math rules are the same if you're a mathematician. So let's just compare. So P, for me, stands for parentheses. Now, spelling parentheses is another game. Let me give it a go. Good thing I got my handy sheet here. P-A-R-E-N-T-H-E-S-E-S. There's parentheses. Okay? Now, when I say parentheses, I'm talking about these things. Okay? You know what a parentheses is. Anything in parentheses you have to do first. I didn't have that up here, but I'll show you some examples later that do have that. They also sometimes use brackets, you know, that are a little bit more square-like. That means the same thing. It's just a different way of drawing a parentheses. Maybe they get bored drawing parentheses. It means the same thing, okay? And the third thing I'll have to prove to you later, okay? A fraction bar results in parentheses, okay? So if I have a bunch of numbers up here and a bunch of numbers down here, okay? If there's a fraction bar in between a bunch of numbers, it's like putting parentheses around the numerators and denominators, okay? So a fraction bar represents parentheses, and I'll prove that to you a little bit later too. Okay, exponents. Exponents. We haven't worked a ton with them. We definitely haven't done it as a topic this year, but I know some of you know about this. So like 2 squared, 3 to the third. I don't know why I doubled up on the numbers. It could be 5 to the third. Doesn't matter. Okay. So if you see an exponent, these little numbers appear, you have to do those next. Again, my example didn't have that. We'll do some later with it in it. Then M is multiply. D is divide. These kind of go at the same level. You can multiply or divide depending on what is in your problem. And then you have addition and subtraction. And those are also, again, at the same level depending on what you have in your problem. Okay, so let's try this with an example. Okay, I'm going to actually pause the video here and restart it so that YouTube doesn't cut me off. I'm going to pause here and make another video with all the examples, which are the most important part. If you don't have the examples in your notes, then that means nothing. This is just gibberish. We have to do examples. Okay, meet me in my next video.